start the recording so that we can then capture it. And feel free to stop me, ask questions. I want to make sure you understand this. So the Dunnington Best Practice Methodology was designed so that you would have a systematic approach to doing analysis, design, and development. As I'm teaching you this, I'm going to also talk about Pega and how that parallels with it. In Pega, you're going to do analysis as a business architect. You're going to do design as a business architect by using the tool to make the flow. And then you're going to do development as a system architect or a senior system architect. Both systems, both way of developing and designing uses object-oriented concepts. In this case, we're looking at Pega. At the end of the day, Pega produces Java. It's a closed system. It won't let you change the code at all, modify the code, but know that you are creating a Java, a J2EE type of application that then will be deployed as a jar. But what Pega does, it takes the jar that you create in Java, puts it into what they call a WAR file, W-A-R, and then they will move that into the production environment or whatever production environment, so it's enabled so that users can get access to it.
Okay.
DBPM helps you assess your problem domain. In other words, what are you doing? Why are we here? In Pega, the business architect answers that question, addresses the question of why are we here? What is our use case? What are our user stories? What are we doing? That's what we're here for. That's what DBPM does from a OO perspective. Produces a conceptual model. It says in essence, who are the entities? If I'm creating this environment, who are all of the major entities that we're talking about? If I'm creating a football game or a soccer game, well, we have the players, we have the team, we have the coaches, we have the referees, we have the field, we have the ball, right? It's a conceptual model. In Pega, you from a business architect perspective is saying, what is the user doing first? What screen is needed first? If I'm going through a long process, am I saying that I need personal information first? Hit the enter key. I then need financial information second. Hit the enter key. I then need underwriting information third. Hit the enter key. I then need credit score information. Hit the enter key. I then need to do analysis. You see that? It's a conceptual model. And then the third thing we're going to do is apply the object-oriented modeling techniques, build hierarchies, build classes, and design collaborative OO systems. What Pega does from your flow, it's doing all of that behind the covers in Java. It's building the class hierarchies. It's designing how the objects will talk to each other. It's building a system. Remember I talked about in Pega you have a application. Inside applications you have case types. Each case type is in essence a Java class. And how do those Java classes collaborate with each other in this object-oriented system? So we have three phases, whether it's OO language, C++, Java, C#, or in Pega, you go through an analysis phase, phase one. Says what? Entity identification. What does that mean in Java? What does that mean in C++? It means who are the classes? In that class, what are the data types? What information should be stored within that? If I'm a coach versus a player, the coach, its information is more about how do I instruct? How do I guide my players? My player, its information that they are managing is how do I run the play? How do I successfully win the game? So we call those attributes. And then methods are the behaviors. How do I do that? How do I make that happen? How do I run? How do I kick? How do I cross? How do I do those things? So we call that the analysis phase, entity identification. In Pega, it's similar in nature, but not as detailed. We're saying in a use case, why are we building this application? What is the as is? That's a term that you'll hear in Pega. What is the as is, and what is the to be? What do we look like today, but what do we want to look like tomorrow? The as is, the to be. So that's the analysis phase. The second phase is the design phase. In an OO language, it's an entity relationship. You only have two relationships, a is-a or a has-a relationship. And that's true in the world also. And that's why OO is a better language to work with, because it's more true to the world that you actually live when you're trying to represent something. So an is-a relationship is always called inheritance. Inheritance says what? There is at least two classes, a parent and a child. And in that parent-child relationship, inheritance says that when I call the child has all of the access to the behaviors and the attributes of the parent. Just like you do, just like my children do. Your name may not be on the checking account, but guess what? Because it's your father, because it's your mother, you have access to that information, to those resources. That's the concept of inheritance. And inheritance, it's not just two, it's two or more. Your parents have parents, they become your grandparents. And you can inherit something from your grandparents. That's part of the inheritance tree. In Pega, we have two types of inheritance. We have pattern inheritance based upon the name of a class, and we have directed inheritance, which is true inheritance from Java. And then we have what's called a hazard relationship. Hazard relationship is composition. That means that I've created a class, but I've put a complex class inside of that class. I didn't put an int or a float or a long or a double, but say that I am creating, I was using the analogy of football, I'm creating a soccer game. Well, in the soccer game, inside of there is a class called a coach. Inside of there is a class called a player, right? So those are not simple data types. They're not int, long, float, double. They are other objects inside of objects. That's called composition. Pega will create composition all the time because each case type is a class, and then you're going to have data types that are inside of that particular class. So that's why I said it's important that you understand this core concept behind is-a and has-a relationship. And then once that's all set up in Pega, the design phase says, as a business architect, I'm taking my user use cases, my user stories, and I'm translating those into Pega artifacts. Is it an application? Is it a case type? Is it a stage step process, which we hadn't talked about, but those are more granular forms of implementations of classes or rules that are behind the covers. And then the third thing we do is we start doing the development. After a BA in Pega creates something, makes it available, turns it over, interfaces with the technical group, which is the system architect or the developer, then they're going to develop out the design. Same thing for an OO language. Once you've set up your classes, once you've set up the relationships with those classes, then you then can start developing it. Pega has a methodology for developing, much like DBPM. We have 9 steps, and then the 10th step is actually the runtime object. All right, any questions about phase 1, 2, and 3?
No.
Tell me the difference between phase 1 and phase 2.
Phase 1 is like identifying like class names, data types, and methods. I feel like I understood phase 2 more, like the is-a and has-a, because the is-a is more like child has access to the parent, like everything that the parent has, and then like the has-a is where like objects are inside of other objects.
Right. Okay, good. Yeah. So let's go back to phase one. Phase one, to give you more clarification, you indicated that you like you watched this show called Games,
Hmm.
right? Some type of games. Tell me the name of the show again, or tell me the actual game.
It's called Battle Camp.
Battle Camp. So Battle Camp would be your class. Okay. No, yeah. So Battle Camp will be your class. In order for you to participate in Battle Camp, give me the major entities that you see on the show. So what is it that you have to have?
You have to be unbeatable, unhateable, and unbreakable.
Okay, unbeatable, unhateable. Okay, but who has to do that? Those are behaviors. Unbeatable, unhateable, unbreakable. But
It's
who is that? Who's doing that?
the participants that they're picking.
Ah, the participants. So with within the, well, I forgot the name. What
Camp.
battle game camp battle camp. Okay, within battle camp you have participants. See that? Participant is an entity inside of battle camp. Battle
Mhm.
camp is a class. Participant is a class, but participant is a data type inside of battle camp. It's a complex, it's a composite type. It's not an int, a char, a double, a float, or long. It is a object within an object, or a class within an object. So when you're describing, that's the analysis, entity identification. Who are all the entities? Well, it's battle camp. It's a participant, right? But you said something. You said that participant is measured by three different actions, and those are what?
Unbeatable, unhateable, and unbreakable.
Unbeatable, unhateable, unbreakable,
Yeah.
right? So those three would be methods. That's the behavior. You see that? So you've identified in this one big class a composite class called participants, and you've identified three methods. Participants is a data type to battle class
So what's the
or game.
difference between Haza and this? Like it sounds like that.
Great. Yeah, so actually that is a hazard relationship.
Oh,
That's composition. That is hazard. You got battle. I keep forgetting the name. Battle, game, and participant, right? So participant is a complex data type inside of battle game. So you've created a hazard relationship. So in your analysis, you would say in that analysis phase, I'm going to create battle game. I'm going to create participant. Give me one more entity. So you got the participants. Is there something else there?
mm,
Where do the participants participate? What's the location?
it's a camp, like
A
with
camp.
like
Okay.
yeah.
All right, right.
Mm-hmm.
So then we have battle game, whatever it is. Battle game, participant, and then we have a camp entity. Because the camp entity is going to have tools or things where the activities take place, right?
Yeah.
So that's similar to Java, not similar to Java. That's similar to Pega. Pega's gonna give you this case type called battle game, and then within battle game, it's going to have these other objects that are doing things too. These other classes that are doing things. So you're going to see composition all the time, but you'll see inheritance in composition. It's always complex. In Pega,
Mm-hmm.
you're not ever creating anything simple. It's always complex. You will always have inheritance and composition at the same time. Make
Okay.
sense? So when we go through the analysis phase, it's simply saying, how do we identify? So for instance, if I created a family object would be Dunnington.
Mm-hmm.
Well, within a family object, I'd create a father object within that object. Well, that's complex. So that'd be composition. I would create a mother object. I would create a child object. within there. So now I got three composite objects inside, or well, yeah, three composite objects inside of a bigger object. Got
All
it?
right.
So that's that is a that's that has a relationship. Now, here's where the magic comes in. If you can do that, if you can create that, then you can do iterative development. And Pega talks about how to roll out development in a iterative fashion. You don't have to know everything. You have to know enough to get started. And then you keep adding to it. And you can add to it and add to it. Well, why can I add to it? Because it's OO. I just add another method. I add another behavior. Oh, I forgot this class, add another class. I don't have to know everything all at the same time. Maybe when I went through my analysis, I thought I knew something. I knew 60% of it, but I didn't know 100%. But that's good. I can get started on the 60%.
Mm-hmm.
And then we can start building from there. When you're working with an OO language, then we look at, in the analysis phase, entities in the problem domain. What we're trying to solve are nouns: employee, student, course, right? Those are nouns. In Pega, they'll tell you that a case type should be a noun. They'll tell you that a stage should be a noun. It is identifying a person, a place, or a thing. So you see the overlap between these OO languages and Pega. You identify attributes to describe an entity. So for each entity, what information must it possess? In your battle game, a participant must be able to remember certain things about the opponent, how fast the other one is, or can they do this better than I can, right? Those are information that I can store. Information I store is different than behaviors that I do. Behaviors that I do affect the information that I store. That makes sense, right?
Mm-hmm.
Activities affect what you remember. Same thing here. So you have, let's see. So all behaviors ascribed to an entity utilizing a Java method. Methods are verbs. Okay, methods are verbs. I'm going to calculate. I'm going to add. I'm going to review. In Pega, when we talk about a stage, no, a step in a process, you're going to use verbs. A stage, you're going to use a noun, but you're going to use verbs for a step in a process. Now, I hadn't told you what a step in a process is yet, but just know that that's the correlation here.
Mm-hmm.
And once we get to Pega, I'll then show you again and say, remember when we were in C++ or Java and I talked about nouns, verbs, now this is where it comes into play. And it gives you an idea of what's really happening behind the scenes too when it's creating this artifact, is creating this Java class, and it's creating these methods, and it's creating these attributes that's associated with it. Entity relationship. It establishes inheritance relationship between entities. Like for instance, a student is an employee. So if a student is working for the school, then that student would be an employee. So I may create a domain that says college. In college, I will have a set of employees, but also in college, I can have a different type of student. But sometimes, these are two separate, but sometimes I can say that a student is a employee. So now that student has all the attributes as an independent student, but because of inheritance, now that student is an employee, so now it has, or he has, or she has the same rights and benefits as an employee that would work for TCU. I can construct a composite relationship in HAZA, which says what? A course has a student. And it can be one to many. A course has many students. Okay. So those are hazard relationships. Pega does the same thing. It's going to create those hazard relationships that says that a course may have a array of students. Very, very complex in that nature. Now you have an array of students for this particular course. I take those two, and then we simply go through the development. What do we do first? Number one, we create a class for each entity. In Pega, we look at what we've analyzed, and we start looking at, is it a application? Is it a case type? Is it a stage? Is it a step? Is it a process? We start mapping the analysis. In Pega, we simply say, or not Pega, but in OO, we simply say, where are our classes that I'll create from each entity? And then step two, I'll look at all the entities and say, what are the relationships? And I create my is-a relationships first. Okay. Step three, I'll look at my analysis and I'll say, now out of all of my entities, what are my hazard relationships? I create my hazard, my composite relationships second. That's all part of the design phase. And then I come back and say, number three, what are the attributes? What information needs to be stored? In Pega, we look at that as a UI. What data elements or data fields do I need in order to represent the information that will be passed as I go through this workflow? Right. And then number five, a constructor. Do you remember what a constructor is from your Java class?
I don't remember exactly.
Okay. Okay, good. All right. So a constructor is a behavior that initializes the instantiated object. It is a default behavior in the compiler that initializes the instantiated object. So what did I just say? I have a class called course. I have a object called English course. And when I get ready to run that in the main, it's going to call a constructor that will initialize all the attributes automatically. Right? Pega does the same thing. When you create a case type and you click that case type to say run the loan process case, it's going to call a default rule that will initialize everything that needs to be initialized. Same concept. So, it uses a constructor.
So is a constructor, you said behavior and you said initialize. So
right. So those are the characteristics of a constructor. A constructor is a behavior that initializes an object at instantiation. You cannot call a constructor after an object has been created. You can only call a constructor, or a constructor is only called in the process of instantiation. So when the compiler gets to that line of code that says this class course needs to instantiate this object, the compiler says call the constructor to initialize all the attributes. And so the system goes and it allocates space in RAM for it, and then it says in this space initialize it.
So pretty much it just makes it makes it run pretty much.
Well, not necessarily make it run. Think of it this way. You just bought a plot of land. But in order for you to build a house on it, now it has trees and all this stuff on it. Now it has to be flattened. It has to meet governmental standards so that they can come and build a foundation and do all the other stuff. So your land has trees on it. It has trash on it. It has all this stuff. And so it is available to you, but it's not, it's not in a place to where I can build a foundation on it and allow you to build a house and live in it.
Mm-hmm.
So that's the essence of what a constructor does. Memory in RAM could have been used by something else, by the OS system. It just freed it up, so it's probably garbage in it. So the constructor says, let me clean that up and initialize it so it only looks like the information or the attributes that you have defined in it.
Okay.
Okay, because if you don't initialize it, like you learn in C, if you don't initialize a space, then you get whatever's there. Okay, so tell me what a constructor is. See if you can verbalize that.
It's a behavior that initializes an object. So if you have like different attributes inside of a class, the constructor pretty much takes all those things and make it, I guess, kind of makes it make sense, and sets it up to the, I don't know if you would call it a method, but
yeah, for that particular object.
Yeah.
Yeah, for that particular object. So think of it this way. Anytime you have a data type, let's take it simple. You have a data type like an integer. If you don't have an assignment statement in C to set it to a 0, like you say int age and you put a semicolon,
Mm-hmm.
when I run the program, and if I say printf age, what is it going to print out?
No.
Maybe it may just print out garbage, because whatever was in that memory location, initialize it. So it's going to print out whatever's there, and it may not be representative of an integer. It could have been something else that might have been representative of some binary data type. And so when you went to do a printf, it starts printing out F, Y, Z, Q, pound sign, right? But what if I said int age equals 10? When I run main and I do printf, what is it going to print out?
10.
Yeah, why? Because you initialized it at 10. So at runtime, it's that value. That's what a constructor is.
Oh, okay. That makes sense.
That's what a constructor is for an object. And an object has more than one, typically has more than one data type. So that constructor says, look at all of the data types associated with that class. And when I'm creating an object and putting it in memory, I need to initialize all of those. Set them equal to something.
Okay.
Okay?
Mm-hmm.
That's the power of a constructor. And we have different type of constructors. We have a default constructor, what I just told you, that if you don't create a default constructor, the compiler automatically creates a default constructor for you. Doesn't really do anything, but it creates it. So you should always create a default constructor and initialize all your attributes. Now, here's a concept that's called overriding. Overriding. I'm using the same name, same parameters, and it's going to override what the system created. Okay, so you always want to create your own default constructor, initialize all your attributes.
Okay.
Pega does the same thing, though. Pega does the same thing. Pega will call a default rule when it's creating an object, but if you don't initialize the data types, it's garbage out there. It's a mechanism to give you an opportunity to initialize. Think of it that way. That's a constructor. It's a behavior, gives you an opportunity during the construction process. You can't call it afterwards. You got to do it during the construction process.
Okay.
And in Pega, we have this process to where
Bless
excuse
you.
me, my allergies again. Ah, all right. So in Pega, we have this process where we have a child-parent relationship, and when a child gets spun off or created, I have a point where I can sneeze. I can instantiate the child and pass it variables during that process. Can't do it afterwards. I can do it during. That's what a constructor is.
Mhm.
Right? It's that mechanism that allows you to initialize that memory going forward. When I say an overloaded constructor is that constructor is going to always be the same name as the class name, but I can pass different parameters. Default constructor, you can't pass any parameters. Overloaded constructor says it's going to be the exact same name, but I'm going to pass it an integer. It's going to be the exact same name, but I'm going to pass it two strings. The exact same name, but I'm going to pass it a char. So I got 3 different overloaded constructors. Okay, so that's what we end up doing there. And then we have a copy constructor that basically says it can copy attribute by attribute. If you got 1,000 attributes, you want a copy constructor because it'll say, just when I create this new object, use my copy constructor to copy and initialize them out of those values. And a lot of times you'll do that when you create a UI. You load the initial values in that UI, and then what you do is you then save that off in a temporary object. So you call a copy constructor to do that. Then you allow the user to make its changes. And then when they hit the submit, you compare what's in this object to your temp object to see what you need to update. Okay. So that's a use of a copy constructor. All of that is for construction. And then the second part is a setter. Do you remember in your Java when they talked about setters and getters?
I remember the names, but I don't
remember the concepts. Yeah. And it's interesting because even when I would talk with engineers at Lockheed Martin and other developers around the world, when I work with them, people don't often teach Java or C++ the way they should. They teach it like it's C or any other language. And if they don't teach you the power behind a method or a setter or a getter, then you miss the essence of the language. So that's why I'm really wanting to take time to show you this. It'll help you in your classes going forward, but it definitely help you in your understanding with Pega and what's going on behind there. That if you end up this year getting all 3 of those certifications, then we work with you. I work with you. Your senior year, you want to be an LSA. You walk away graduating from TCU and you're already an LSA. The world is your oyster. Now, you may want to do something else, but then know you got this in your hip pocket. I can do that. I'm so far beyond where people are. It took me 3 years to get my SSA. But that's because I was working all at the same time. Never did get my LSA. You come out and you have an SSA your junior year and your LSA, you're working on that. That just makes a huge bit of difference. Okay. So anyway, that's what we're shooting for. A setter says this: after an object is created, what do you want to set me to? What do you want to change me to? What do you want to update me to? So that's a behavior that gives you the capability after an object has been created, you need to modify it. Could be that example of the screen is up, the UI is up. User entering information. Now I need to update the object. But what do? I call a setter to update the age, update the name, update the date. That's what setters are for. There's a format for all setters. All setters have a void return type. The setter name is set, S-E-T, followed by the attribute name. That's how you create the method. And then whatever value you want to pass it. And then, of course, within your statement block or your curly braces, then you then set the values that need to be set. You'll see that for a setter. A getter does what? If a set sets, what does a getter do?
It gets the updated version.
Yeah, well, not the updated version. It gets the most current version from the object.
Like after it's updated?
Yes, after it's updated. That's correct. Or it could be after it's been instantiated. Right? Because let me give you an example of a getter. You log into your mobile banking application. You log into your banking application, you put in your ID and your password, it evaluates it, it calls the database, brings back your information in memory. Now I have to call a getter to get that information so that I can then set that information to the UI. I get it from my database object so that it comes into my current object. Now that's in my current object, but I need to set it to the UI object. Everything in Pega is an object. You set, get, construct, set, get, right? And that's how the process works. So getters will say what? Getters typically say, you don't ever pass me anything inside my state, inside my methods, in my right or left parameters. You don't pass me anything in, but you're going to always return me something out. Getters never have a void return type. I'm sorry. Yeah, getters never have a void return type. Absolutely. All right, so
name is get, like similar to set.
Yeah, so it'll start with get, G-E-T, followed by the attribute name. Then you'll have the right and left parentheses, followed by the statement block.
Okay.
Okay. You have yes. What's your question?
Oh, it's clicking because I feel like I've seen those get and sets, and I'm like, okay.
You have.
But it hasn't never really been explained. So.
Yeah. Yeah. You have teachers teach it from a syntactical perspective and not from an OO design perspective. If you get the design, that's why I gave you the one for Java, C++, C#. I give you design. All three of those languages work the same way, exact same way. Syntax is a little different. The nuances is a little different, but it works the same way when you understand it like this. Okay, Java has a finalize method. C++ does not. C# does not. Finalize associates with the garbage collector. Remember in Java, you have a garbage collector. In C++, you have to free everything. Remember in C, you have a function called malloc?
Yeah.
Right? Malloc says what? Dynamically allocate memory. And then you have to make sure that you deleted whatever you freed. Or yeah, you then had, I actually don't remember the C function for you to do. In C++ it's delete, but you would have a pointer, you would malloc, but then you would have to make sure that you null that pointer. That's the way that you would do, right? In C++, Instead of malloc, they used an object called new. Inside of new, they called malloc, right? But then they had another keyword called delete, where you would then delete it. It would mark it for deletion for the garbage collector to come along and remove it.
Okay.
Okay. So finalize basically says anything that's open file streams that are where you're reading and writing to files, reading and writing to database connections, communication endpoint like queues, MQ, things of that nature. That's where you want to close it.
So anything that's like empty.
Anything that's active and open, and you're at the end of your program and it needs to be closed, then you do it in the finalized method. In Pega,
So
you don't.
it's done.
I'm sorry. Repeat
Is it pretty
what you
much
said.
saying it's? Is it pretty much saying
Yes.
like it's over?
Yes. Absolutely. Absolutely. And in Pega, we do have what's called a final stage. A final stage does the similar thing here. When it's the last stage of the workflow in Pega, then that's when you want to end everything. Now, you don't have to be as technical to say close streams, is that Pega takes care of all of that, but that's your final wrap up. Your final wrap up, which says, I'm not going to do anything else in Pega. Okay. And then we have step 9, where you start creating different methods for specific behavior. You got your setters and your getters. Those are always common. And your constructors, those are always common. And then you have certain methods. Well, in your battle game, you have a participant. They all have those 3 behaviors in common that they work with. But what makes one win and another one lose? What's a particular behavior you're watching the game and say, oh, that person does that better than that? What can you give me an example?
Like for example, there was a spelling bee competition. If one person has more knowledge on spelling, let's say they read more books, they might have an advantage over the other that really didn't care about spelling and probably just typed everything.
Got it. Okay. So you would then create a specific method or behavior called knowledge level, right? Or type of knowledge, something like that. And there is no naming standard for the other ones. You then can have your own, you can call it whatever you want to. But typically in Java, C++, C#, they use something called Hungarian notation. Y'all talk about that in Java? You ever hear your professor talk about a Hungarian? So Hungarian notation means that the first word is lowercase, like set, S-E-T. And then the next word, if it's a combined word, you capitalize the word. Like set name, the N in name is capitalized. So that's called Hungarian notation. That's how you have a rigid way of defining or creating attributes and methods.
Okay.
And so when you have your specific behaviors, you're doing calculations, you're doing computations, you're doing decision analysis. That's exactly what you do in Pega. Pega has a decision shape. Pega has a shape that allows you to do calculations and computations. Same thing. All Pega is a high level, I like to say white tablecloth presentation of a low level detailed implementation of Java. Instead of
So
you writing all of the specificity, you call the decision shape, it writes all the Java for you. You go to each of the tabs and you configure what you want them, like the methods getting parameters being passed in, and then it's going to do all that for you at runtime.
So is it kind of like you're writing a paper and then you have like your like intro paragraph, but then you have your body, like that's the specific behaviors, like the body.
It is. Yes.
Okay.
Yes. Definitely. Definitely. Okay. And then, of course, you get into the main logic. So think of your main logic as it's actually running, right? It's that you so far all you've done is define a class hierarchy with its relationships as is-a, has-a, with the attributes, information that it will store in any behaviors, along with constructors, setters, and getters, and unique behaviors. Now you've created the monster. Now you want the monster to walk. You want it to talk. You want it to get out into the world. All of that was so you could build a system. Now you want it to do something. You want to turn it on. So what do? You run your program. What do you do in Pega? You run your case type. When I run my program in an OO language or I run my case type in Pega, what happens? Instantiates an object. What happens? Calls a constructor to initialize all of the other complex objects in it. And then it goes to the next step. Or in an OO language, I go to the next line. When I go to the next step in Pega, guess what it does? It looks at how that's configured and says, oh, what object do I need to instantiate? What methods do I need to run? Here it says what? What objects do I need to instantiate? What methods do I need to run? Does the same thing. Does the exact same thing. It evaluates it, makes a determination what the execution path is. What do I do next? Do I go to the next line? Do I loop? Do I skip? Do I do a conditional if? Pega's the same way. Here's my condition logic. Here's my routing. We hadn't talked about routing. It will change its path based upon some condition. It'll do a spin off. It'll spin off to some other parent or child. All of those things are happening. Two different
Okay.
ways. Okay. All right. So I've talked an hour. Time for a break. So let's
Okay.
take a break. Come back at 11:45, and then we'll actually go through an example.
Okay.
Okay.
Sounds
Sounds
good.
good. All right. See you in 15 minutes. I'm going to
All right.
pause the recording. All right. Let me resume the recording. It's up and going. All right. So we just talked about the three phases, and I gave you details about phase 3. Quick review. Tell me the three phases of the model, DBPM. What are the
Three
three phases?
analysis, which is entity identification, design, which is entity relationships, and development, which is class construction and object.
Very good. Phase 1, entity identification. What are you doing there? What are the three things that you're doing?
You're identifying your class name, the data types, and the methods, pretty much everything that keeps on going under the class.
There we go. Number 2, phase 2, design. What are you doing there?
You're creating and HAZA relationships, where ISA is like your child has access to the parent, and then HAZA is like you have objects and objects and objects.
Okay. And in phase 3, the first 9 steps, you're doing what? In summary, you don't have to give me each one of them, but what are you doing?
I feel like you're pretty much like, I don't know, for me it's like it seems like you're just designing your program. Like you're just like creating creating what you want to do. You're creating setters and getters to make sure you have that information updated if need be, initializing everything, and pretty much taking all the steps to just make the program run in its entirety.
Yeah, yeah. So that's the final step of design, to where you're really building all of this. You're really not doing any development at this point per se. Development is actually um, the execution or the running of what's being configured. So you're in that process of configuring. You're configuring this so that when it happens for real, all of my methods are in place, associated with all of my classes, all of the attributes are where they should be. I have all my components in place, all of my tools that I need to do what I need to do. So now step number 10 is let's run it. Let's run it to make sure nothing's missing. If something is missing, that's the iterative nature. In Pega and in big companies, they use Scrum, SCRUM, and they use sprints. They sprint every 2 weeks. Every 2 weeks, they meet, they look at it. You know, Scrum is like what is that? Football, Australian football, where they're in a big huddle, you know, and they're getting ready to fight for the ball. That's a scrum. So they come together and then they take off. Then they come back together. That's what we do in IT. Everybody uses Scrum versus Waterfall. Waterfall was everything had to be in place before you go to the next step. We don't do that anymore, except for people at Lockheed Martin. You don't want Scrum in an iterative environment when you're creating a jet. You don't want to be changing all the time. You need to know everything about this. Then I'm going to create this. Then I'm going to create that to create a jet. So there are some unique use cases where people still use what's called the waterfall approach. 90% of the world that you're going to be working with, it's always Scrum. It's iterative development. It's 2-week sprints. You meet, you move forward. Okay. So what we're going to do is walk through an example, then we'll take a lunch break. We'll come back. We'll look at the environment. I want to make sure that you're comfortable with this because it goes a long way of learning Pega. If you can get this, then when I'm talking about things that's happening, you can imagine what's happening underneath the cover. That's going to be a huge advantage for you. So let's look at phase one. Phase one, entity identification. Here we have, let me ask you the question so I'm not talking so much. How many entities do you see here on the screen?
3.
3, yeah. And they are what?
I don't know if you're talking about the example, like the employee student course.
Yes. So you got employee, student, and course. Those are your 3 classes. Those are your 3 classes, or they will be classes. That's what I want you to know. Remember, this is phase one. We're not using syntax in C or C++ or Java. Same thing is true in Pega. In that analysis phase, we're looking at why are we here? Who are the personas? In Pega, these would be the personas. These would be, oh, we have an employee persona, we have a student persona, we have a course persona. See that? Well, maybe course may not be a persona, but these two would definitely be personas. But this would be probably a case type or a data type for a given case. Nuances, but they're still classes, right? They're still classes at the end of the day.
Mm-hmm.
But these are entities. So let's take a look at it, see if you can tell me how many attributes do you see in each class and what are they?
It's 3. It's social security number, score, and title.
Right. All right. Now notice at this point, we hadn't assigned a data representation for that. Normally in C, you would say what? Social security number would have to be some numeric integer. or long, maybe a long. Score is probably an integer. Could be a char, but integer. And then title is, you would say, a character array, but here in Java it'd be a string, just forward. But remember, in this phase, we're not thinking syntax. In Pega, we're not thinking syntax at this point. We're saying, what are you trying to do? Oh, we need employees so that we can say their social security number. We need students to say their score. We need a course where we say their title. That's the conversation that's going on. So that's what you see here. These are the entities. These are the three attributes. The behaviors are what? The methods that act upon the attributes for a class. That's what they're designed for. So remember what notation I said this was? When it caps each word, remember the term? What's the notation? Capital Y, capital E.
Was it the has, starts with an H. Oh, the Hungarian notation.
Hungarian notation. That's exactly what it is. All right. And see how easy it is for you to see this? Compute years employed, calculate test scores, all right? Analyze student mix. Very, very easy to read. Now, I do something a little different in my methodology. Attributes, when you see we create them as within a class, I put an underscore. Anytime in a class, it's a class attribute, I'll put an underscore. And I've done that because I used to analyze the C compilers all the time, and they would do that. Most people don't do it, but what it does for me is I know when I see an underscore on an attribute, I know it is associated with some class. If I don't see an underscore at the end, then I know that it's a variable being passed in. Very, very small nuance, but it's big when you're working on an enterprise application. Okay, so now we're going to look at this. Here's our design phase: entity relationship, is there or has there. So what is that first picture saying to you?
It's saying that the student is an employee,
That's
and
right.
I guess like all the information that the student has, the employee has. Or not has, but is.
Uh-huh. Yeah. So all the, say that last statement again.
Not has, but is.
Yes. So, but all that the employee is, the student is. Right. So that's the is a relationship, parent. So which one is the parent? Let's make sure that you're clear on that. Which one is the parent? Student or employee?
Employee.
Right. Employee is the parent. So does student have access to social security number?
It should.
Yeah. Remember the simple statement, everything that the parent has, the child gets. As parents, we know that very well. Your children figure it out after a while, right? Everything that your parent has, the children get. So the student is an employee, which means that everything that the employee has, the child gets. So if I create a student object, can I call the compute years employed method?
Can you ask it again?
Yes. If I create a student object, can I call at runtime the compute years employed method or behavior?
I think yes.
Yes. And that's because of inheritance. Student inherits all behaviors of the employee. Student inherits all the attributes of employee. So I don't have to do any redundancy there. If I'm a student and I need to compute something because it's an employee, I don't have to write my own method to do that. I can use the one up in the parent. But if I wrote my own method in a student, that's called overriding the behavior. Now that makes sense, right? There's a behavior up here, but if I write the same one here, I'm overriding what the parent does. Right? So that's a concept of overriding. Pega, you're going to read when you go to that section, there's overriding of classes. They do that. There's 3 different ways of overriding, and one is class behavior. Right? So that's the is a relationship. What is this picture saying for the has a relationship? What does that say?
The course has a student.
Right. And you see that student is a class or an object inside of this entity course. How many attributes does course have?
2.
2. Which one of those attributes is a complex attribute
Student?
or an object? I'm sorry, what did you
Student?
say? Student, yeah. Because you look at title in C, you would say, oh, that's just a character array, or you say that's a string. That's not considered complex. Student is, because it's one of those objects we created, one of those classes we created, but we define it inside of the course. So this is design. Pega, you're going to do design. You're going to say which artifacts go first. Which artifacts, is it a UI? Is it a decision? Is it a compute? You got to make those decisions. Is it a decision where we go this way? Do I route? That's a type of decision. All of those things come into play. Do I send a notification? Right? All of those things come into play. That's the design. All of this is all of the design. So you're going to design that, eventually give it to a developer so he'll develop it and then run it. In your case, you're going to be the designer and the developer, like what you're doing here. All right, excellent. So that's phase 2. Now we move into phase 3. Once you learn the format, man, it's really simple. What are we doing in Java that's a little unique? We have package. We got to include the package name. Remember I talked in Pega and I showed you briefly yesterday, there were 200 plus rules in Pega? Packages. That's really what they are at the end of the day. Those 200 rules, Pega has to eventually translate or convert those into packages. Remember I showed you the little place where it created Java in that data transform. You saw all of that. Well, it included those packages. Same concept here. Use the class keyword to define a class. We call that a user-defined data type. That's why a student was a data type inside of course. Those are user-defined data types. We have keywords like private. Private says no one but classes in its inheritance path can access it. So if a parent has a private attribute, no.
The child can't access?
No. Yeah. Wait. Back up. I just gave you a definition of protected. Private says no one can access it except that class. There's no visibility. That's the key word that we use in OO. There's no visibility other than inside of that class. It is only within the scope of that class. That's another way of saying it. Scope and visibility. Where can it be seen? Where can it be accessed, right? So if it's private, then no one access. If I make it protected, that means anyone who has an is a relationship with me has direct access to it. So if I have a parent and I have a protected attribute, then my child can directly access that. Okay. And then
Is
when I
it,
say,
wait, what's the same,
okay, what's your question?
is, uh, isn't that like pretty similar to private then?
It is similar to private, but it's giving your children access to you directly. The difference is this: your dad has a bank account and your name's not on it. That's private. Okay. Protected says your dad has a bank account, but he adds you as an authorized user. That's protected. Okay. Now, I can't get to it because I'm not part of the inheritance. Make sense?
Yeah.
Public says what? Public says anybody can get access to it. A general rule of thumb: never make anything public. That's an attribute. Never. Unless there's an exception. There are use cases where that's an exception and you want to make it public, but generally you have to have a reason to make it public. It's going to be private or protected. Okay. Your initial thought should be anytime your initial thought should be all of my attributes are private. Just by default. Everything should be private. Right. And the reason I say that is why? Because you have getters and setters. You want getters and setters to manage your attributes. All of your getters and setters are going to be public unless otherwise there's an exception. So I can still have a child or even a class outside of my inheritance hierarchy that if I have a public setter or getter, I can still manipulate the private attribute. Make sense? All right, so then we go and we
Yes.
create a constructor that will initialize the object. It's going to constructor instantiates the object, so finds a place for it in memory, and then does the initialization. We're going to do a setter and getter, so you can manipulate your data. Finalize method, so that any cleanup has to happen, and then you want to create any special behaviors. And that's the format. That's the format. In Pega, you're going to create an application. Application's going to have case types. Case types are going to have stages. Stages are going to have steps. Steps are going to have processes. And underneath the cover, it creates all of those. That's exactly what's happening. Never write a piece of code, but it's doing all of that. Okay. So this is what it's going to look like. And then we'll take a lunch break. This is what it looks like. You're going to have your package entity name. You're going to have your public class along with your entity name. You're going to have your private data type with the attribute. If you won't protect it, if you had an is a relationship, then you may want a protected attribute here so that that child can get to it. It's up to you, but you can always use your getters and setters. Here's your default
You don't have to
constructor.
declare that?
You never, no, that's the difference between C++ and C. No, this is actually a declaration in itself. Once it is defined and declared all at the same time. Little nuance between C and C++. Okay. And let me tell you this: the size of the object is the sum of the attributes. Let me say that again. The size of your object that's going to be in memory is the sum of your attributes. Methods are not considered in memory. They're in a different part of the region at runtime. The size of your
Okay.
class is the sum of your attributes. Okay? So this is a default constructor. It has the same name as the class, no parameters, and it's going to do initialization of all of the attributes. In this case, there's only one. And we typically use this as the keyword to say this is the class attribute. Remember I talked about in C++, I'll use an underscore, but in Java, I can use the this keyword. So it's this attribute for a particular object. Here's a constructor. Constructors always have the same name as a class name, but it is going to pass in a parameter. So I take the parameter, assign it to initialize the attribute. That's called overloading. I have more than one method with the same name, but different parameter lists. Overloading the name. That's polymorphic behavior. Many forms, same name, different actions. Setter, right? It's always void. Notice all of these are public. Now, all of these are public. Void with set, and then whatever the attribute name is here, capitalize the A. And then the parameter that I pass in, I set that parameter to the attribute. Other one is the get. I never pass anything in. You could put void there if you want to, but it's going to always return out the data type of the attribute. Finalize method, anything you need to clean up here, you can put it there. And then your specific behaviors, method 1, method 2, whatever you want to do, method 3, method 4, whatever else that you specialize. Maybe you're drawing a circle or you're keeping up with distance or whatever, that's what goes there. But you use Hungarian notation for that. Okay?
Okay.
All right, so let's go ahead and break for lunch. Come back at 1:15.
Okay.
Sound like a deal?
Sounds good. Sounds good.
All right, talk to you later. Now, okay, so the recording is on. So let's take a look at the 10 steps when we're going through now and doing the development. It's analogous to Pega. You're doing the design of the workflow, building it out, preparing it, getting it ready, making a roadmap, as it were, to what you're trying to do. And then actually developers come in, Pega, that would be step 10 here, and actually develop it out. So let's take a look at, first step is creating a class. Remember, we created the classes from entities. So question, how many classes do you see there?
3. Well,
3.
Yeah.
Yeah, that's, you know what? Well, no, not 3. There's
The public class
4.
threw
Yeah,
me
so
off.
yeah, so there's actually 4. Yeah, because when you're in Java, the name of the public class has to be the name of the file, correct? So you do have
Oh,
4 classes there. You have 4 classes there.
right.
So that's what now you have to remember that about Java. It's more Java, it's more object oriented. in its design than C. C is a combination of C++. C++ is a combination of C with OO concepts. So in C++, you still have the main, which is not an object at all. It's a place of execution. In Java, you have to have a class where the actual main is inside of it for the execution to occur. So you do have 4 classes that are there: employee, student, course. The curly braces, the appropriate name, those are statement blocks. And statement blocks give scope and visibility. That comes into play. Scope means where it can be seen, or access. Visibility means where it can be seen. Let me say that again. Scope is where it can be accessed. Visibility is where it can be seen.
Okay.
Static, the keyword static indicates that there is only one copy or one version. It's not an instance of. So you can't have multiple instances of main. It's in memory. Memory is broken down into dynamic memory, static memory, and other. We'll just leave it for other for right now. So when things are put on a static part of the memory, that's called the heap, H-E-A-P. I don't know if you guys learned that in your assembly class. Talk about the heap and the
We did.
stack,
Yeah.
pop on, push on, pop off. Okay, right. So that's how that relates to this here. It's important at this level of programming, not as important in Pega, but Pega, again, they use Java. So you have things that are dynamically on the heap that gets allocated and what's on the stack. From a data perspective, that's important. From a design perspective, if you're a BA, doesn't really matter, doesn't mean anything to you. Number 2, create the is-a relationships. So read that line to me, explain to me what that's saying from a syntactical perspective.
It's saying
For class
that,
student.
yeah, it's saying that the student is pretty much a of employee, so the student is pretty much extending information from employee.
Right. And we call that, they use the keyword extends. You see extends, it means to inherit. Right. Student inherits from employee. Student extends employee. That tells you a couple of things in the design. Employee is designed in such a way we have methods or behaviors and attributes that are now available to student. The student does not have to redo. They can he or she can simply utilize it. Step 3, has a relationship. Explain that syntax to me. What is that saying?
So it's creating a class source and it's putting the student inside of the course.
That's correct. And that's how you establish a hazard relationship, because we know that student is a user-defined case type or class. Same name, user-defined case type means a class. We use the keyword class for user-defined case type. So student is a class. Student is a user-defined case type. We create a data type or an attribute called student, which is within the course class definition. And remember, we said that the size of a class course is the sum of its attributes. So if I was to ask you, well, what is the size of course? Well, course has one attribute called student. I'd have to go to student to see how many attributes it had and count up the sum total. Integer 4 bytes if it's a 32-bit machine, long is 8 bytes, and you would go from there. But you see all that in memory. Number 4, create the attributes. Now that I've created the class, now I create the attributes. So explain those statements to me for the 3 different classes. How would you say that to me in English? Look at the syntax.
Okay,
What does
so
that say?
you have a class employee, and then you're creating a place to put social security number in there, and it says it because that's going to be a number. And then it says student extends employee, so that the student has access to employee's information, extends a score. So that is an as well because it has to be a number. That's another attribute. And then there's another class course. It doesn't extend anything, it's on its own. And it has a string title. So you can have the title of the course, that's an attribute. And then as a private student, so that means that it has like student has a relationship with employee. Wait. Wait. No, student has, well, yeah.
You're actually right. Yeah, you're right. Student has a relationship with employee. All right. So when I instantiate a course object, how many attributes are actually created? So now I'm
It's
wanting you to
either
think
1
like the
or 3.
compiler so you can see it. Huh?
It's either 1 or 3. Because
Okay.
I say
So
1 because it could be just title, but then I say 3 because since it has a relationship with the employee, then it has social security attribute, score attribute, and the title attribute.
right. So actually it's 4 though. Right? Title, student, score, and SSN.
Oh, okay.
Oh, see that? Okay, so make sure you see that. Now, what that's telling you is course cannot exist until student exists. Student cannot exist until an employee exists. So guess what happens in memory? In memory, when it tries to instantiate course, it says, oh, I can't do it because student's not instantiated. So it goes up to student and says, hey, I'm getting ready to instantiate, create memory for student. Oh, I can't do that because employee's not created. So it goes and it creates employee. It allocates space based upon the size of SSN. And then it comes back and it calls a constructor for employee. Then it comes down and says, now I create student because employee exists. Now I create student, I allocate space for him, and I'm pushing these on the stack. These are being pushed on the stack. Now, student is on the stack with score. Then it says, now I can create course. So now it creates title, and then it creates the student attribute. So now you have 4 attributes that are contiguous in memory on the stack, with student being the highest attribute. And we'll see that when we run the debugger later on. That's important because in Pega, we have the clipboard that does the exact same thing. Okay, it's going to show you memory that's on the stack, and they're going to show you memory that's on the heap. And we call those data pages in Pega. Data pages dynamically allocate things. Anything dynamically allocated is put on the heap and not the stack. So it has a longer persistence. Its lifetime is longer than those on the stack. A stack frame only lasts the scope of a statement block. Okay. So remember that a stack frame only lasts the scope of a statement block. Okay, so That's what we do there in step 4. You create the attributes. Now, step 5, you create the constructors. Tell me again, what's the definition of a constructor? A constructor is what? And it is initiated when?
It's initiated when, like, I know a constructor is a thing that pretty much like realizes like an attribute.
An object, an attribute within an object. So we typically say, technically, that a constructor is initializing the instantiated object. Okay, which says what? All of the attributes that are within that object.
Yeah.
Okay.
So
So
you want me to explain this?
I'm sorry. Go ahead.
Were you asking me to explain this code?
Yes.
Okay, so we have the employee class, and it creates an attribute, the social security number, and then it creates a constructor for employee, and it sets social security number to 0. And then it creates another overload. Well, no.
Yes, that's it. That's called an overload.
Then it creates an overload constructor, and it passes the social security number into it. And it says social security number equals social security number. I guess that's from the previous employee to the overloaded one. And then it creates another constructor, public employee, and it passes employee in, and I guess, and then it sets the social security number equal to the employee social security number.
Yeah. So remember, that's when, for instance, if I want a template, you and I both are employees, I get hired first. And so here's my employee information. If I just want to copy my information to your information and then modify, I use a copy constructor. Because it may be a list of 100 things. Well, no, everything's not going to match, but let's use a copy constructor of an existing. I want to create a new employee. When I create the new employee, Caden, I want to pass in the Daryl employee information. Now it's just going to copy everything over. Very, very simple way to do that. Okay, so in essence, you have one class, one attribute, 3 constructors, 2 overloaded constructor. The first constructor is a default constructor, which requires no parameters to pass in. The second one requires you to pass in an integer. The third one requires you to pass in an employee object. Okay. So the only thing I want to correct in your statement, you said this dot assign is equal to Social Security. You have to read it from right to left. They may have taught you that in a similar left-hand operand, right-hand operand, equal operator, right? An operator in the middle. So you want to take the right-hand operand, assign, it's not equal to, equal in Java is equal equal. A simple single equal sign is an assignment statement. So you're assigning the passed in social security number, which is temporary on the stack frame, onto the class attribute SSN. Just a nuance, but it's a big difference.
Okay.
In Pega, we have something called a data transform. Data transform, you take whatever's on the right-hand operand, assign it to the left-hand operand. And then it's a rule, so it's like a class on steroids. You can do if then else logics. You can do copy constructor types of things there too. But that's what's happening underneath the covers. Okay, so that is a format that the DBPM follows. So it does it for every class. So what is this for the second class?
So it's creating a relationship where the student extends employee, so the student is a employee, and creates the attribute double score, and then it
Excellent.
creates a default constructor, which is student, and it assigns score, well, it assigns 0 to score, and then it has another overloader constructor, so it has student, and then it passes it in as a parameter double score, and then the double score passing the parameter is assigned to the previous score, which was set to 0.
Mm-hmm.
And
No,
then
no, no.
we have
Okay, wait. Yeah, so that's a point of confusion people have. You're simply defining it right now. It's not overriding the previous statement. So what the compiler does, it takes all your class definitions and loads it into a place in memory. It doesn't do anything until we get to main. When we get to main and something is called, then it goes up there and it executes it. So none of this is being executed right now. So when this is done and this is done, this doesn't override that and this doesn't override that. No, this is saying that at some point in time in main, if you create a class object, you want to create a class object and you don't pass me any statements with it, I'm going to call this one. If when I'm in main and you want to create a student object and you pass me a double, I'm going to call this one. Okay. So these are different behaviors that will affect score, but they will only be, and these are defined for you right now, but they won't be utilized until you're in main and you call
them. Okay.
That's the difference between C++ code and C code. C code, it's run sequentially. C++ code is scanned, loaded in the memory. It finds the main statement block, which is a static statement block, and then it executes it.
Okay.
Okay. All right. So now go ahead and finish the last statement here.
Then it has another constructor and it passes in the student constructor and it names it student, and then it copies it by assigning the student score to score.
Right. For this object when it runs at runtime. Okay. And then the third class.
So it has a class named course, and then it attribute string title, and then it creates another attribute that has a relationship to connect student to say that student has a relationship with course, and then it creates a default constructor assigning title to basically null, and then it's another constructor, the overload constructor, that passes in string title, and it assigns that title to the original title, and then it creates another constructor, and then this one is for the second attribute, which is student, and it assigns student created in this constructor to the original student, and it creates another constructor, which is also an overload, and it takes both the title and the student, and it assigns the title, passing the parameter to the original title, and it takes the student, assigning the parameter to the original student, and then it takes a copy constructor and it passes in course, and it assigns the course title to the original title, and it assigns the course student to the original.
Boy, that could get convoluted really fast, right?
Yeah.
Writing all this detail, writing all of this detail over and over and over again. And I'm going to show you how we'll be able to take this format and give it to an AI. It'll suck in the format, and then all we have to do is prompt it, and it'll do it all for you. Yeah. But learning is learning how it's to be done. That's why we're going through it so you can understand it, makes you appreciate it when you have a better tool that does it for you. A lot of the environments, though, I think MS Studio, I think there's a feature, auto feature. It'll create constructors and constructors, setters, and getters for you. I think. I know NetBeans will do that. Xcode will do that for you. But that's because when you're trying to build a class, you want to think of everything that it can do, all the different ways that it can be constructed. And these are all the different ways that it can be done. I want to show you two different nuances, though. In the title, the string, we use the double quotes, kind of like a null, set it to nothing. So that's typical what you do. But notice what I did with student. The student is an object. I can't use the double quotes because it's not a string. Student is an object. I set it to null. So you have to set it to null. You can't use a string or zero or something else. Number 7. Okay. Only tell me what's happening in the class for the getter and setter, because you've already told me about the int and the constructors, but skip to the getter and setter. So what's happening in employee?
Okay, an employee, it creates a setter and its return type is bool, and it's called get social security number, and it passes the int social security number into the setter, and it assigns the new social security number and the parameter to the original social security number.
Okay.
And then it takes a int, it returns an int type, and it gets the social security number, and it just returns the social security number.
Okay. Absolutely. So only one correction in your verbiage. It's not really the original social security number value or whatever. It is it's just the social security attribute. It's just the attribute for that object. Okay. Because it may not be the original at a setter. That may happen at the very end of the action in main, anywhere. So anytime you see setter getters or constructors, they're acting on the attribute of a class.
Okay.
All right. How about for student and employee? Skip all the way down to the getter and setter.
Okay. So it creates a set score, and it returns void, and it passes in a parameter, which is double type and score, and it assigns the score in the parameter to the attribute score, and then it has a get score that returns a double, and this just returns score as a double.
Wonderful. All right. And then the last one, much more complex object. Skip all the way down to the getter and setters. You got 2 of them.
Okay. So it creates a setter. It's going to return void and its name set title, and it passes in the parameter string title, and this assigns the title and the parameters to the title attribute. And then it also creates another setter for set student. This also returns void, and it passes in the parameter student, and the student passed in the parameter is assigned to the student attribute. And then it starts with the getters. So we have get title, return a string, and that'll return the title in string type. And then the next getter is called get student. So this returns student, and it passes it back in student.
Excellent. So I think you're getting the understanding of the format. Now you can see there is a certain way to create a class, define the attributes, define the constructors, define the setters, define the getters. And notice that every attribute should have a setter and a getter. And it should only be one attribute that you're setting or getting. If you're doing more, then it's not called a setter or a getter. It's just one of those other methods that you're doing. But every one of the attributes have setters and getters. And notice that the name of the setter and the getter is the name of the title prefix with the word setter get. I'm sorry, with the name of the attribute prefix with the word set or get. That's the way. The only
Yeah.
difference of in this in C++, of course, you got semicolons at the end of the class statement blocks, and instead of using the keyword this, we use title is title underscore student underscore. That's the only difference. We don't have that concept of this object in C++. All right. So here's an example of the finalize. I'll do that one. That's an easy one. It's just protected. What does the keyword protected mean?
That means it is like only to be shared with those who have a relationship with it.
Right. And what type of relationship though? Is it a is-a or a has-a?
Is-a?
Is-a. That's correct. It's inheritance, right? It's inheritance. That makes sense for it to be in a has-a because a has-a is already part of the object. So finalize, I didn't put anything in it, but you could put whatever you needed to do, whether you got to close a open file or a database connection, clear up memory, free it, end up doing that. Same thing here for employee, same thing for course. All right, so now we get to step 9. Step 9, explain to me the statement after finalize. What is that doing for employee?
It's set. It's creating a method that void called compute years employed, and it passes in the parameter and social security number. And yeah, that's it for that one.
Yeah, that's it, because
And
I didn't
then
really write
for
any
the
logic inside there. Yeah, right.
yeah, and then for the student section, it creates a method, the calculate test scores. It passes in the parameter score, and it returns, it assigns the attribute score in the parameter, and this is assigned to the attribute score, and that returns a double.
Yeah. So
And
notice what
then
we're doing. It's a bit more complex, but all of this is the right hand operand. It's doing calculation, then it just assigns it into the left hand operand is always a placeholder or a data type.
okay.
All right, and then the last one.
And then for course class, it creates a method, analyze student mix, and this returns void.
Absolutely. Okay. So this is an example, though. These are simple classes. It's only 3. I work with people that like eating Martin. Sometimes we'd have 100 classes. So it would take us a week to figure out 100 classes. What data do we want? What data types do we want in it? What information do we want stored? Take another week to figure out what's the relationships of all 100. Someone we got right, someone we didn't get right, we'd have to revisit, we'd have to redo it. Pega has something called an enterprise class structure that does that for you. It has based on a naming convention, and you'll have thousands of classes, but Pega can manage those. You have to do this manually, and you do. Some people, they decide not to use Pega, they still use Java. They decide not to use Pega, they use C++ or C#. So that's a full stack developer. You got to know all of this. You gotta know how to do this. So Pega's competition is those Java, C#, C++ programs. When I would go and work with people and companies, big banks would buy Pega, they would say, well, we just selected a group of our developers, OO developers, to learn Pega too. And so they were always struggling with, well, I want to see the code. Well, no, you got to understand the concepts. And it helps you build enterprise solutions bigger, better, faster without the nuance of having to do all of this stuff. This stuff, when you get on huge enterprise projects, you got 8 people working on it. They're in different countries, and you're trying to run a sprint every 2 weeks. Man, it's a lot of pressure. It takes a lot of effort to keep it together. Okay. And so now you get into step 10. Step 10 says what? Everything from my package all the way down to right before my public class, all of that's just a definition. This is what I can do. Now, inside of here, this is what I will do. If I have not defined what I can do prior to get into the main, then I can't do it here. Some definition has to exist up there in order for me to be able to do it. So for instance, let's walk through this example. This is a very simple example. All of this has been defined for you. Let's walk through it. See if I can get it all. Let me minus. Now I can get it all here. Okay. Almost do another minus. It's gonna be too small after a while. Okay. There it is. That's everything. And of course you got it on your screen too. So when the compiler runs, it's going to load static memory first. So that main gets loaded out into the heap, not the stack. It's on the heap. There's a single entry point into it. And then it starts executing sequentially now. None of this is executed sequentially. Sequential execution starts here. The keyword new student, this is a constructor. So it says, new says, I need you to instantiate me an object. Student constructor says what type of object I want you to construct. When you construct it, I need you to assign it to this object name. So 2 things happen. There's memory being allocated, and there is an object in memory that's pointing to it. In C, we call that a pointer. In C, we call that a reference. Do they have? No, I'm getting confused. Do they have references? They don't have. Yeah, they have references in C. Yeah, in C, there's a reference, the address of operator, right? Address of operator.
Yeah, there is.
Okay.
Yeah, because
So
you have that
you
and
got references. That's right. This gives you the address of the actual point. So just know there are 2 entities in existence here. the object itself and the pointer to the object, or we just call it the object. So which constructor in my definitions will it call? I got three classes up
The
there.
student?
What is the compiler doing? The student, but which one of the three student constructors is it calling?
The default?
Absolutely. Why? What does the compiler do? It
It
matches
takes that
name.
default and
Yeah, but in order for
yeah.
it to find it, it matches name and parameter list. Okay. And it simply goes here and it sets it to 0.
Mm-hmm.
Okay. So that's what happens on student. But what else gets created when I create the student object? Student extends employee.
All
So which constructor gets called?
right. Is it the uh is it the overload?
You would think the overload, but no, because you didn't get an opportunity to pass it anything, right? So it's going to call the default constructor. See that? So remember, children can't exist until parents exist. Well, that makes sense in the real world, right? You can't exist. You didn't exist till your parents existed. Same thing here. If I'm creating a student object and student extends employee, this can't exist until I make this come into existence. So
Mm-hmm.
which one gets created on the stack frame first, student or employee? Gets pushed on the stack.
Employee?
Yeah, right. So it has to be created. So we push it on the stack first. After it gets created, it gets initialized, or SSN gets initialized, then it comes back down here and says, now I can create student. And it calls this constructor and it initializes it. So now student is the sum of the size of those two attributes, double score and int SSN. So if someone asks you what is the size of company student, it's the sum of the attributes in those two classes. Pega, you'll have to know that if I'm going out and I get information from the org, which is at the top of the enterprise class structure, and I'm all the way down in the implementation layer, then I have access and I got a big object. It's a big object out there. Okay? So one of the challenges with Pega is you got to have huge machines run them. They're typically clustered together so that you have enough power. You can't just run Pega on one server. It's normally a cluster of servers to make that happen. Okay. All right. So that's it. That's in memory. All right. So what is this statement doing? Which method is it calling?
Which statement are you talking about?
This one that I have highlighted. Company student dot set SSN, and I'm passing in a number. What is the compiler looking
That
for?
is it's looking for, it's under the employee class, and it's pretty much updating the social security number for company student.
Right. Now that shows a great example of inheritance, right? What type of object is it? This is a student object, but it's calling an employee method.
Mm-hmm.
And why can it do that? Because we made it public. Okay. If it's public, anybody can access it. Well, that's what we want when we want getters and setters to be public so that anybody can access. I created an object. Now, I could have made it protect. Well, no, you don't make getters and setters protected. But if I had a protected one, then it could still access it because it's part of the inheritance. All right. Very good. So
Okay.
now what is this statement doing? Now this is a simple statement, but it's very complex as far as the operating system is concerned about creating objects on the stack, having multiple stack frames and making it available. So talk me through it. What is the compiler doing?
It's creating a new object, and
Okay.
then course, and then it is calling the, what is that?
So
Is
you,
it calling the title? Wait,
you got 5 of them to choose from.
I
Look
think,
at look at the parameter list.
it's calling the loader constructor number 3.
Number 3, which would be this one. You think it's that one?
The
No,
number 3.
3. Yeah, you're absolutely correct. That's exactly the one it's called because it's matching a string here and a student object here. Absolutely correct. Excellent. Excellent. All right. So then what is this line doing? Which method, which behavior is it calling in which class?
It's calling under, and it's getting the title attribute.
There we go. And then the last one?
Yeah. And then the last one, it's creating a method, and it's under student, and it's updating the test score. Well, it's updating the score to 95, and that's getting, I know it's not a sign because it's a dot, but I guess you can say it's combined with the student.
Yeah, so that's a little complex. So you're looking, here's the course. This is a course object, right? This is the course object. But I want to get a student test score, calculate a student test score. Well, I happen to know that since this is a course object, in my course object, I can get the student, because that's an object here, that then can allow me to call the calculate test score that's up here. Okay. So that's how inheritance works. Very, very popular. Now I could have done it in 2 steps. I could have got the student and get a temporary student object and say, now go get the calculate test score. But I can concatenate and string those with the member of operator. So it creates a dynamic object in memory, and then it passes it, and then it pops it off the stack. So once it runs up here and does this get, it gets that object, and then it goes and it gets this object, and it pops it off the stack. Then it brings this back up to the current stack. Get access to it. Okay. All right. Wonderful. Wonderful. So that's how that system works. That's how that best practice methodology works. Hopefully that gives you great understanding. I think you do, of what happens in the compiler, what happens with in memory, stack frames, the heap, the stack, all of that comes into play when you look at what's called the clipboard. Is like a big debugger in Pega where you take a look at that stuff. Okay. All right.
Okay.
Any final questions about that?
No questions. That
Good.
helped a lot.
Wonderful. Let's open the one in C++. Now, I won't go through details here. I'll only show you the nuances so that you can look at and know the differences between C++ and Java. Let me know when you got it open.
I have it open.
Okay. So we follow the same thing. Phase 1, analysis. Phase 2, entity relationship. Phase 3 is development. Nothing changes because these are the same types of language by nature. And we have the steps 1 through 9, that's the exact same thing. Then we have the step 10 inside the main. We follow the same steps about the is and has. The only difference, and this is where I'll show, and I won't get into all of the gory details. Let me make it a little bigger here. That's too big. Okay, yeah. So here you see that in C++, you have the header files, like in C. You have header files. They don't have the double quotes. They have the less than, greater than, what gets you to the library, or we call it a namespace. So this is getting you to the namespace, similar to a package, but not really. And then you have your class that you're defining. Now, we use private with colon, protected with a colon, instead of saying putting private and the data type all on the same line. Public with a colon, and then you specify all of these. Everything else is exactly the same. The constructors, the setters, the getters. Only difference is we have a deconstructor. Java, you don't have to worry about deconstructing an object or pushing it off the stack or out of the heap, because the garbage collector figures out if it's not going to be touched anymore, then it's going to release it. C++, you don't have a garbage collector. Garbage collector, you have to write a deconstructor. So this is with the tilde, similar to the finalize method in Java. In Java, there's a finalize method where you're releasing everything, but you have a garbage collector that's going to get rid of all the objects. Here, you don't get rid of the objects unless you delete them. There's a keyword called delete in C++ that you have to use. And you want to call that within the deconstructor. If a constructor initializes something upon instantiation, a deconstructor releases everything upon deleting. Okay. Hold on just 1 second. I'm gonna put you on mute. Someone's at my door. That's my son being nosy. Oh, I thought it was someone. All right, so everything else is exactly the same. All right. But I want to show you the nuances, because I can quickly, people will ask me sometimes, well, are you a Java programmer, C++? I said, well, what do you want me to do? I can do both of them. I cut my teeth on C++, so I'm better at that. But if I got to do syntax and I convert some to Java, it's easy for me to do because I follow this best practice methodology. Works all the time. Some other nuances: when you create a class, remember now you have to put colons at the end of the keywords for private, public, protected, and it has to have a semicolon at the end. Java, you don't need a semicolon at the end of a class, but you do. This is considered a statement in C++. Syntactical nuances. In C++, I don't use the extends keyword. We don't have that as a keyword. I use a colon, single colon. That says student extends employee. That's an ISA. For the housing
Okay.
relationship, nothing unique about it. I just put student and then I use that underscore student as my attribute. So now this student course has a student data type or object.
Okay.
When I create attributes, we don't use the this keyword. We just put a underscore at the end of the class attribute.
Okay.
For the constructors, nothing changes except for you never need the void or you don't put void on constructors. Oh, I don't think you do that for Java either. So everything's the same. Everything's the same. When I use a copy constructor in C++, I have to use the reference, the address of reference to do that. Okay. Mhm. Getters and setters work exactly the same way. So we don't put the underscore in the method name, only when I'm defining it. And then notice when I do the assignment, I'm assigning 0 to SSN underscore. That's how I know that it is a class attribute. Java, we use this dot SSN. Right. Step 8, you got deconstructors versus step 8 in Java, you had finalize method. Here you have deconstructors, and it is the same name as the class name preceded with a tilde. And that's to free up endpoints, communication points, memory, whatever you have to do. Similar to the finalize in Java. But it's definitely always needed when you're creating objects. Step number 9, other methods that you create, they work exactly the same way. Okay. All right, so let's take a look at step number 10 when you actually create it. C++ works the same way as Java. Two-pass compiler. C is a single pass compiler. C is going to start from the top, execute from the bottom. Java, C++, C Sharp, two-pass compiler. First time he's loading the definitions, comes back. Now he's ready to execute. So these are all the definitions. And surprisingly, kind of looks the same, except for I don't have to put equals new. In Java, to create an object, I have to say new to make that happen. Never have to do that in C++. When I say student, company, student, it knows, hey, you're asking me to call the default constructor to make this happen. When I come here, the setters is exactly the same. Here I'm creating course object-oriented language. I'm passing the title and the student object. Again, it comes here and it calls this constructor right here, number 3. Just nuances in the language, right? Never have to use the new keyword in C++ when you're instantiating something. And here we do the get title and we do the calculate. All right, so that's that one. come back and let's take one more look at now. Have you had an opportunity to do C#?
No.
Okay, let's take a look at C#, because if you can do C++, if you can do Java and you can do C++, you can also do C#, following the same methodology. Weird, why is this a little bit smaller? Okay, follows the exact same phases, the 3 phases. Phase 3, 1 through 9, exactly the same. Scroll down to, let's look at creates. So it uses using system, kind of like that package in Java, like the namespace, and it
Mm-hmm.
says using entity name. That puts it in within its namespace. So that's a difference in the syntax. Got to have those. Okay? Now everything else is exactly the same. C# is more akin to C++ because it has a deconstructor.
Mm.
The classes is much like Java. You don't have to have the semicolons at the end. So what C# did, there was a big fight between, should we do Java? Should we do C++? Microsoft didn't want to do either, so it wrote C# and it tried to take the best of both worlds. So you'll see some variation of Java, some variations of C++. But it does have a main. So like Java, it has a main. So you could take any Java program and quickly convert it over to C#.
Mm-hmm.
But when you create an is a relationship, it uses the syntax of C++. For the hazard, it's the same for all three. For the attributes, we use the attributes like we do in Java. We have the private, protected, public. Here you see that we use the same syntax. We use the this keyword. So they do a mixture of C++ and C in Java. It's just weird, but anyway, you just have to know the syntax. For the getters and setters, nothing changes for all three. For the deconstructors, for the destructors, you use the tilde. So C# does not have a garbage collector like in Java. So you do have to have the destructors. I've been calling them deconstructors, but they're destructors, not deconstructors. Step 9, any other method you want to create works the same across all three platforms. And then step 10 for the main logic. So C# is a 2-pass compiler like Java and like C++. So it loads all the definitions first, looks for the static main to start the execution, and it uses the new keywords like Java. So it's always easier for me to translate
It looks
anything from Java to C# or from C# to Java, and then I can go down to C++ if I want to.
it seems more like Java besides the destructor.
It is. It is. And it gives you a few extra keywords that are really good when you're trying to do different things. And that's why some companies choose C# because they are more in the Microsoft camp and they can do Java/C++ with that language. All right, so hopefully that gives you enough understanding about object-oriented concepts. We spent a lot of time there, right? But I wanted to make sure that you get a base understanding of the Pega environment. It's all about OO. Pega started out up through version 5. It was C++ as the language that they interject. And then they got rid of C++, and from 6 point on up until 8 now, they use Java. It's a unique architecture where they've built a language like Java converts into a neutral machine language, and then the runtime compiler converts it. That's what Pega did. Pega has this middle layer that's called language, and it can take any language out and substitute it in, and the way you build its artifacts will still work with it. So they went from C++, they took that language out, put Java in. Today is Java. Next year, they may take Java out and put some other language in. So very, very versatile in what it does. So where are we? Let's take a look at Claude. So let's get you up and running on Claude. Show you how to use that. And you should copy Claude.ai. You know what? I'm going to stop the recording here for a bit. It's just walking through. We spent the whole morning talking about Dunnington Best Practice Methodology, all the nuances, all the details. And so now, what I would typically do if I'm teaching a C++ class or Java class, now I'd start giving students exercises. You guys write this. I want you to create a jet. This just has one attribute. Follow the DBPM methodology, write out all of the attributes, the classes, go through all 3 of the phases and do it. Well, it takes a while to type all of that, but that's part of the exercise. Now comes Claude AI. It can actually take the Dunnington Best Practice Methodology in. I said, use the DBPM to create a jet class with one attribute called model type. And I copied and paste in the methodology. You see that? Copied and pasted it in.
Mm-hmm.
And so it says, okay, I'll create a jet class with one attribute called model type using Dunnington Best Practice Methodology. Let's walk through each phase systematically. And here it took that and it says, okay, I've created it. Phase 1, entity relationship. I've identified that I have one attribute. Okay. Behaviors, it created 2 attributes in setters. Phase 2, it says, well, it's simple. It's just one class. There's no is or has a relationship. Phase 3, it says, I'm going to create a jet class. No relationships. I'm going to create the model attribute. I'm going to create my constructors, all 3 of them. I'm going to create my setters. I'm going to create my destructor. I'm going to add my business logic. And I'm going to create the main so that it'll create an object using the default and pass some parameters in the copy constructor. I'm going to demonstrate the flow execution. I'm going to call the object. Wow. So it did all of that. And you look over here, it wrote the program for me. And it put the comments as to what each one was. And it did it in C. Okay.
Oh, wow.
So here's model type. So we spent the whole morning going through all of that. Had I given you an assignment, it would have taken you another hour to type it. Now you come to AI and say, hey, here's the methodology I want you to use. I give it the right prompt. And I say, here's the prompt that I want you to utilize. And look how short the prompt is. Create me a jet class with one attribute. That's all I asked it to do. And it comes over here and it follows the methodology. It makes comments And here's my default constructor. Here's my overloaded constructor. Here's my copy constructor. Here's my setter. Here's my getter. Here's my destructor. Here are my business objects, my methods that I have. And then I drop into main, and it says, okay, cout is like printf. So I print this out. Jet default jet, now it calls the default constructor, and then it displays that information. It comes back and says, now I'm going to create a specific type of jet. I'm going to call it an F-16. It passes in the F-16 string, and then it does a display, so it's going to display it. Then it comes back and it says, now I'm going to create a copy constructor. Now I'm going to take the F-16 that already exists, and while I'm creating the jet copy, it's going to have the same parameters in it. I'm going to display it. It should display the same thing. And then it comes back and it uses the setters. Which one's easier? Of course, the AI version. That's exactly what Pega is going to do for you. Okay? Pega uses generative AI. Pega uses predictive AI. They have a whole new tool called the Blueprint Gen AI that you can give it prompts and it will write your application, your case types in your workflow. People are good from a business perspective that can do that, but people are better when you're technical and you understand everything that's happening. Right. So I'm introducing you to this so you understand how to leverage what you're learning here in C++ and in Java with Pega and see the technical correlation. And it helps you along the way as a computer science student understand there are some tools out there that can really help you. Okay. So the other thing I want to show you, and then I want you to do, I'm going to show you this. So this is the Xcode compiler in the development environment. Looks simple, but it's very comprehensive. Very comprehensive. It has everything MS Studio has, but 10 times more. It's a very robust environment to use, and you can develop, as I said, everything from on this OS to all of their devices where they have different types of OSs to make that happen. So what I did, I went in, I told it to create me just the initial program, and that's what it does, is it creates this. And then I said, okay, I commented all of this out. By the way, what you have, well, you have that in Java, you have the / in Java, so I don't need to talk about that. All right. But yeah. I then took the model that was generated from AI, copied and pasted right into here. Exact same program, right? Only differences I made is I know in C++, I need to do that using namespace std so that I don't have to explicitly qualify that every time I call it. You don't have an issue like that in Java, but in C++, if it's not in the namespace, then you got to explicitly call the namespace if you want to call one of the behaviors. Right. Well, me adding that, then I told it can remove the std : everywhere. And I think I added the IO. Did I add the IO string? No, I actually didn't have to add anything else. That was the only change that I made to this AI code. All right, so in your debugger, you have the capability to set breakpoints. Can you tell me what a breakpoint is? Are you familiar with breakpoints?
No.
Okay, So in the debugger, since it's going to run in memory, then you can have it pause on a statement, so then you can see what's in memory. Is it what you expect to be there? So it's an incremental way of debugging without writing printf statements everywhere. That's typically what we would do, right? Put printfs before, put printfs after, trying to figure out what in the world is wrong. Well, now I can put breakpoints in my environment to stop it and pause it so I can see what's going on. I have that same capability when I am working in a Pega environment. I can run my case type and I can pause it with a breakpoint so that I can see what's on the clipboard in memory exactly to see what's out there.
Okay.
Okay, so this environment helps me do that. What I'm going to do, take this breakpoint off, shouldn't be there because this is just definitions. And I'm going to start right here because that is where everything is being executed inside the main. And I'm going to run it. Now, in this little window, nothing's here right now. I know it may be hard to see. I don't know how to make it bigger, but it's going to show me what's in memory. Pega calls it the clipboard. So let's take a look. I'm going to run. It builds it, compiles it successfully, and it comes, sets me a breakpoint, line 77. At this point, I should have created an object called default jet. And I want to display what's in default jet. Well, here I can look over to the right, maybe hard for you to see. It tells me it's creating default jet because it calls the constructor. Where is jet? Let's just go up to it. Jet, when I call the default constructor, it initializes model type to unknown, and it tells me it's the default constructor being called, model initialized unknown. That's exactly what you get here. Lets me know it did that constructor. Right?
Mm-hmm.
And then I tell it to tell me using the getter, or no, we didn't use the getter. I could have used the getter, but I used the display info to tell me what's in it. And of course, it's set to unknown. That's what's printed on your console. What is it called? STD out, STD error, STD standard. You know those from C, right? You got to write those to the console. Yeah. Here is my in memory on my top stack frame. You see the object jet of jet type. In that object of jet type, you see that there's a model type attribute that's set to a string and it's set to unknown. In other words, I can see what's in memory, exactly what's going on. What's in my stack frame? What is my stack frame? My stack frame is main. So everything is visual. Everything is within scope. The life of all of these objects is the life of the main stack frame. Okay, so I will continue to run, and I'll hit run. I'm gonna run from 77 to 80. Oh shoot, no, cancel. Hold on, that's not what I want to do. I want to come here and continue. So I hit continue. It went from 77 to 80, but between here on line 78, I created another object of type jet called F16. So if I look over here, I should have passed it to the overloaded constructor that passes in a string, and then I display it, and then I tell it to fly. So over here, you see it calls the overloaded constructor, and it's set to F16, and then here, jet model, it says it is that particular jet. So let's look at it in memory. In memory, how many objects do I have? I have 2. One is default jet, and then I just created F16, and it has a model type, and it's set to F16. Now, this is on the stack, but you got to look at it. It's kind of backwards because you pop on, you push on, pop off, but it shows. So this is at the bottom of the stack frame. This is the current stack frame here. Or I should say, it's the current object, but this is all within the stack frame of the main. So it's not really stack framed at this point. It's just objects being added in memory in some location. All right, so I can come back here and say from 80 to 84, I'm going to create another one, but I'm going to use the copy constructor. So I'm going to get the same type of information. So I'll hit run to make that happen. And you'll see that it created a copy constructor, and it's called the exact same thing. And now you see that here is jet copy. Okay. And then I do a run one more time. It's just going to print out information. I do a run, and then you then see that all of these objects that are in memory, they then get removed. That's how the debugger works. And that's how you learn to understand what's happening in your OOA languages and in Pega, knowing that an object gets created and what its scope and its life is, and you have tools where you can look at that. Here in these languages, you have your debugger to do that. In Pega, you have something called the clipboard. Any questions?
No, no question. That's pretty cool.
Yeah, really, really cool. All right, so this is what I want you to do. I want you to go back to this environment, see if I can create a new one. Yeah, I'm through with you. I should be able to come here, a new chat. Okay. So yes, now, yeah, so and it keeps up with what you've done before, so you can go back to it. So that's pretty cool. All right, so here I want to do some code again. I got my own look over my code design database. Right. So it's not giving me the same options. I just want to do other. Well, that's weird. Because you actually had an option, right?
For
Yeah, so write test. I don't want to write a test case as well. Okay, I can. All right. Okay. Well, actually, what I'll do, I'll see how smart it is. I'll just start right here, see what it does. So let's copy and paste in. Let's use Java this time. I did C++. Let's see if it can do Java. So let's come back to the DBPM for Java. And you only need to copy the last 10 steps. Actually, you know what? I think you need to copy the whole thing because you need the phases. Do see what happens when you do this. That's gonna copy everything. Actually, you know what? Let's just do the 10 steps here. It's not gonna print out the phase stuff for us, which is fine. We just wanted to mimic this stuff. See if I can copy.
hello?
Yes.
Oh, okay. You can hear me now?
Mm-hmm.
Oh, okay. You froze for a minute. Can you say what you were
Oh, okay.
copy again?
Yeah, so we just want to copy in phase 3.
Okay.
Okay, so let's do a copy. Go back to Claude and let's say create a Java program for a jet class using the following methodology. Let's see if this works. Then I typically put up here, don't hit the enter key because that makes it start running sometime. And then do your paste.
Okay.
Oh, that's not copy it. Let me go back and try to copy it again. Did not copy. Come on.
Mine isn't copying either. I think I'm gonna try to do a screenshot.
Yeah, yeah, that'd be interesting to see if Claude can read a graphic.
Hmm.
Let's see. So I tried that. Try to do Control V. Nope, still not doing it. You are right. It's not copying it. Let's see. How did I do that the other day? I just took the. I you know what? Try downloading the PDF to your local drive. I think that's what I did the other day. I just downloaded it to the local drive. Okay. And then open it and you're in preview mode. In preview mode, you should be able to, let's see, if I do a copy and then I come over to Claude and I do a paste, see if it works. Yeah, it works.
Okay,
Right.
that worked for me too.
Actually, let's see.
It's actually making it.
Is it making?
Yeah.
Okay. I'm gonna run it too, so it's pondering.
This is so cool.
It is, and it's a huge time saver, right?
Yeah.
It's crazy. Ah, you can see it's creating it now.
Yeah.
Now it called it aircraft. It's
Yeah.
using its own creativity, but I said jet, but I could change it. So.
It like switches to jet. At first it was using aircraft and then it used jet as it kept on going.
Oh, did it?
Yeah, for mine.
Oh, I see what it did because this is Java. The main class he made, I think he made oh man, it's writing a huge.
It's definitely a lot more code than the previous one.
It is, right? And see, it's using some of its knowledge about wow, some of his knowledge. Since it's a large language model, it's going out to the internet, pulling all this stuff, and he's building his perception or design for a jet. My goodness. And that's the thing about an object-oriented application. What you're building is your view of what you want. When I
Mm-hmm.
worked for Burlington Northern, when they talk about a railroad, well, what is a train? A train to some people was the engine with all of the box cars. It's a train to some people in the boxcar division, that was a train to them. A train to finance was the actual revenue that's generated from the movement of one to the other. So when we would go into a class or when we'd go into an analysis session, we'd ask them, well, what are you guys looking to do with the train? And that would dictate the perspective that we would create.
Mm-hmm.
Okay. So I said jet to AI, and
Mine actually like paused. It said, what did it say?
this is
I
huge.
think mine might have been doing too much because it like
Mhm.
paused afterwards and it was like the capacity.
Yeah.
Yes.
So yeah, so this one ended up, oh my goodness, this one ended up creating a menu system. Because it has print line, jet, class demonstration, number one, Boeing, number two. Then it says which one did you select? Select the jet. Okay, so that tells you a little bit about AI. You got to give it prompts, the right types of prompts. My prompt was too open, right? It was actually way too open. So you could then come back and say, see, he created a comprehensive Java program, followed the 10 steps, aircraft, engine, jet. So now you can come back and say, that was too comprehensive. Use only the methods in the methodology. And that's the essence, though, as you're learning everything that we want you to learn. But the key is for you to help us create the right prompts. As we're using all these tools, how do we go to Pega, Blueprint, GI, AI, and say, we need you to do this for the UI. We
Mm-hmm.
need it to look this way. What's the best way to say that? All right. And so we'll utilize your time to help us focus on how to do that. Teach you how to talk AI, and that's putting you in the place where now you understand what a prompt engineer is. And
Yeah.
if you follow that path, right, what's actually going on. All right, so here it comes back and it creates something. He says it's simple. It says, let me create a simpler version using only what's indicated in the steps. Okay, better. So now he's telling me, now he's going through all the steps, but he still created a aircraft engine and a jet. Why? Because aircraft is a parent, engine is a separate object where an aircraft has a certain type of engine, and jet extends aircraft. Why? Because jet is a type of aircraft that has an engine.
Mm.
That's what it went created. And it tells you it went through steps 1 through 5 and 6 through 9. And then it had the objects that it instantiated. So let's come back and look at it. Where am I? The new one. Yeah, so here, though he did, but he created a whole lot of get engine, get capacity, get passengers. So it's still created a whole lot more. Step 2, where's my step 1? but because it created the hazard relationships and the is relationships, it ended up being bigger. So let's see if I can say, okay, now reduce the code to only a jet object. Okay. That's a little simpler. But it
Yeah.
still created a lot of attributes, right?
Mm-hmm.
Wow, 1, 2, 3, 4. So when he's doing that, then he's going to create getters and setters for all of those, and that's what makes it so big. So here's a default constructor, but this is a great example. This is what you'd work on if you're going to work for a company.
Mm-hmm.
You're not going to have a simple jet. You're going to have the engine, the aircraft, the jet. You're going to have all of that. And typically, since you're pulling from a database, it's going to be 15 to 20 attributes that you're going to have. Sometimes 40. In Pega, typically we have 40 attributes that we're always pulling. So it gets fairly complex, right? Easy and fast. But if you know this setter getter format, if you know the DBPM format, it's easy for you to identify what's actually going on. So yeah, so this one is much easier, much smaller, and then it creates the JET program. Okay, so now you got a tool. Now you got a tool, and you also understand you got your development environment. I put in the chat the URL for you to download Xcode. I think Xcode is good for you to get access to.
Okay.
I'm gonna stop the
Hopefully.
recording.